in part C, we are asked to draw, to graph, to chart a risk profile, a risk analysis, risk profile for this game, for this operation. Why are risk profiles important? Think about you being at the expert in your company, the analyst in your company, giving advice to a superior, to your boss, to your supervisor, whatever that is. You go there and you say, hey, do Space Pirates. You're going to get 724. Thank you, bye. Well, that's probably not a good answer, because your manager is going to have a few questions like, okay, how likely am I to get 724? What are other possible outcomes out of this if we go with Space Pirates? Okay, so yes, 724 means it's the better choice, but what could happen? What could go wrong? So that's why we create a risk profile. And a risk profile shows each of the possible payouts and the probability that those payouts are the ones that actually take place. So if you go back to Space Pirates, and now we're only doing the risk profile for Space Pirates because Space Pirates is our recommendation. So look at these payouts, or payoffs. There are 6 of them. But if you look at them, right? Look, 800 and 800, 400 and 400, and then 1600, and that's it, right? And 200, 400, and yeah, exactly. So we have a couple of pairs. We have a couple of payoffs that repeat themselves. So what I'm saying is that, look, if you sell Space Pirates and you have competition and the demand is medium, you get $400. But you also get, or you could also get $400 if there's no competition, but there's low demand. You also get $400. Okay, so you need to figure out, first of all, how many possible payouts do I have? So judging by what I see here, you only have 800 is a possible payout, 400 is a possible payout, 1600 is another possible payout, and 200 is another possible payout. I only have 4. There are 6, but there are only 4 possible payouts. Okay, so you're going to draw a chart for each of them. Okay, do I have them in this order? Well, they should be, yeah, you have to make them, get them in an order that makes sense when someone is looking at them. Whichever order you want, ascending, descending, but okay, like that. Is that how I have it? Yeah. So this is what I'm going to do. I'm going to draw a chart like this, 1600, 800, 400, 200, and the height of that bar is going to be the probability of that payoff happening. So let's take a look at 1600. What's the probability of 1600? Okay, 1600 only occurs one time, which is here. And the probability of 1600 is going to be the probability, the multiplication of the probabilities. Remember, like tossing the coin? You guys did this right. When you were trying to figure out the probabilities of getting tails twice in a row, it was 0.5 times 0.5. Well, the probabilities of getting 1600 are 0.4 times 0.5. Right there, right? 0.4 times 0.5, 0.2. So the height of this bar is 0.2. All right? 800. When does 800 occur? 800 occurs twice. It occurs here and here. And the probabilities of that happening are going to be the multiplication of each of the individual probabilities added together. So it's going to be 0.4 times 0.3 plus 0.6 times 0.3, because we have 2 possible scenarios where this could happen. So 0.6 times 0.3 plus 0.4 times 0.3 equals 0.3. So 800 has a probability of 0.3, 30%. Okay? And you do the same for 400, which is another case where you have two instances, two scenarios, and then 200, which is easy, just like 1600. 200 only occurs here, so it's going to be 0.6 times 0.3, 0.18, and that's it. And if you want to see how I did the graph, it was that simple. Okay, I just took those. What kind of, is this a, yeah, this is a, yeah. No. Yep, sorry. Ooh. Okay, there. There you go. Okay, that's how I did it. And then I just changed the colors with these little skulls and bones, okay, for fun. But that's how I did it. All right. And finally, part D.